Hello, my name is Alex Halliday. I'm Director of the Earth Institute, and on behalf of the Earth Institute, our faculty and staff, and most importantly, our student researchers, I would like to welcome you to the annual Earth Institute Student Research Showcase. Each year, students undertake impressive research throughout the United States and abroad. They work alongside Columbia faculty and researchers, collecting and analyzing data to better understand the Earth systems. In doing so, they gain valuable hands-on research experience and help to develop solutions to pressing environmental and sustainability issues. Though we cannot convene in person at the moment, today we are gathering virtually to celebrate the important work of all our student researchers. This year, 123 undergraduate, graduate, and doctoral students from across schools at Columbia were funded through the Earth Institute student programs. These include an internship program, an undergraduate research assistant program, a travel grant program, and other fellowship and grant opportunities. In total, the Earth Institute awarded over $100,000 to support students. The topics included biodiversity and urban planning, earth sciences, international development, a huge range of material. Though the students did not travel as extensively this year due to the coronavirus outbreak, international research still took place in a variety of places, including India, Israel, and Guyana, for example. At home, students have gained hands-on experience while working in various Earth Institute centers, in particular the Center for Climate Systems Research, CESM, the Center for International Earth Science Information Network, the Center for Sustainable Urban Development, the Center for Sustainable Investment, the Lamont Doherty Earth Observatory, of course, and actually others as well. Today, we are featuring 20 students who will talk about their work. After the video, these same students will be available online to answer your questions live.
New York City has a really diverse housing stock. We've got skyscrapers, we've got single-family homes, but most of them have been built before the 1970s. And so if we're looking to make policy that will mitigate urban heat islands, it's a little bit easier to prescribe best practices for new buildings. And it's a much more daunting challenge to look at retrofitting some of the older housing stock. But it's a challenge really worthy of our time because the houses that need retrofitting are also the houses where people are suffering and dying from heat-related illnesses. I found working with some of the professionals that I worked with to be the most rewarding aspect of my research. I was able to speak and learn from people who've been working in scientific research and design and policy and social activism. Being able to benefit from their experience and their dedication to urban heat islands and urban heat island mitigation really informed the process through which I was able to conduct the research with the help of the Urban Design Forum, and kind of has led me on a path for greater exploration into the ways that I could apply my research.
As a collaborative research grant recipient, that is a program that seeks to pair graduate students with well-renowned faculty and mentors, it was challenging in the beginning to narrow down exactly a very concrete research project that was at the same time feasible in one academic year and impactful at the same time. I'm mostly interested in understanding perceptions around climate change and how to bring social change and behavioral change that allows people to closely align their values with the decisions they're taking. The most rewarding element was being able to do field work in different parks across New York City, being able to interact with the diverse populations that live nearby these parks and learning so much about New York's diverse communities and the way they perceive climate change. The qualitative research that we've been doing in parks across New York City over this project is key to better understand our users' needs or citizens' needs, and as a policy sustainable development student, it's critical to understand our users' need to better develop policies that target these specific users in the best way.
Human exposure to heat extremes, it is right now at unprecedented levels in many parts of the world. and this has serious consequences in terms of health, food security, productivity, and many others. Our project contributed to the growing dialogue surrounding vulnerability and climate change. We started our project here in New York, and then we traveled to Dhaka to conduct an ethnographic study. We learned that people are well aware of the problem. They have a strong notion of the relationship between materials and house structure, and they are well aware of the consequences and causes of heat. This practicum was as much a personal journey as it was an academic exercise. We deepened our knowledge on climate change. We understood more about the current coping strategies in this community. We learned about best practices in different parts of the world in the use of cool roofs. But I think the most important thing for us was to be able to actually be there, to talk to the people, to learn from them, to hear them.
Even though my paper is about the economic and the environmental impacts of Guyana going through the oil industry, what it came down to was the political side of things. So a lot of what's going to be the outcome of Guyana is going to be left within the hands of good governance, good leadership, and politics. Even though there's the economic dynamics and the environmental dynamics that are at play, it's really in the end just going to mostly what I found is going to be boiled down to good governance and the political arena. I had the ability to conduct reputable research and asking the tough questions to the right people. A lot of developing countries or developed countries have a lot of resource booms. If it's oil, if it's gold, whatever natural resource that is becoming in abundance, and they're discovering it and seeing how they can capitalize on it. I think that this project that I started with regards to the oil industry in Guyana can be templated for other countries that are going through similar resource booms or even going through the oil industry.
Colombia has some of the best climate researchers in the world, all put together in one organization, the Lamont Doherty Earth Observatory, so that's why I came to Colombia. We wanted to test a hypothesis about how high sea levels rose during the last interglacial period, which is the last time Earth was 2 degrees warmer than it is today. I learned a whole bunch about doing field research as a carbonate sedimentologist, exactly what I was hoping for when I came to grad school. I learned a lot about coral reefs, both now and in the past. As we've been hearing about with the Great Barrier Reef, coral reefs are the canary in the coal mine for climate change. So studying them both now and in the past is important if we want to understand how our climate system is responding to human activities.
Well, I really like the content. I've always been interested in sustainability and often on the technical side of food and agriculture, but now I got to see a whole different side of the whole field. I'm studying chemical engineering at Columbia, and one of my professors said that the job of an engineer is to take really big problems and break them up into small, solvable pieces. So I want to kind of apply that skill in the field of sustainability. My research supervisor is developing the project further. She went to Rwanda over the winter and plans to return over the summer, and the work I did helped her narrow in on a set of questions to ask during in-person interviews with farmers.
I spent the summer of 2017 in the Land-Ocean Atmosphere Interactions Group. I spent most of my time in that lab working on their NASA-funded interdisciplinary science project on water quality modeling and carbon cycle dynamics in the Long Island Sound. I particularly enjoyed learning about how to combine remote sensing satellite data with observational data and comparing these analyses both from sampling station to sampling station and over time. I was really grateful to be able to participate in a field cruise, so I was able to actually generate that observational data that we were processing in the lab. I also developed my lab technique skills, my computer programming skills, and I was really thankful to be able to learn more about workflow in an academic environment.
I took a course taught by Vidor Chopra in issues of belonging, And what I found is that there's this interesting connection as it comes to young people's feelings of belonging and how that really talks to and speaks to their feelings at school and their future aspirations when they are in the school environment. The students reported, at least that they identified, that belonging was when they felt a connection with others based on past experience or backgrounds. And what it tells me is that there is a sense of a revitalization of their identity when they come to the school that I conducted the research at, that they shed their vulnerable pasts and they really begin to reform how they belong, who they belong to, and how does that then connect to the person that they will become. This grant allowed me to peel back a few layers to really get at where is the future of peace building going in Rwanda, and where are the pitfalls and where are some of the successes that we can expect to see in the future, particularly from this population of orphan and vulnerable youth.
This research is mainly a geophysics research, and by doing it, I confirmed that this is the field of earth science that I want to pursue in the future. So in the time I have left at Columbia, I want to take classes that are related to this subject in specific, so I can have the economic basis I believe I'm gonna need in the future. This project can be developed further by comparing the regions where these seismic anomalies are located to microcontinents around the world, because by doing this we can get a better picture of the mantle structure of the planet itself.
Through this project, I've really expanded my understanding of how chemistry happens in the atmosphere, how gases react with one another in the atmosphere to form pollutants. And specifically, the pollutant that I'm looking at is ozone at the surface of the Earth. I found my research, and I'm continuing to find my research, really rewarding because it's a field of inquiry that occurs at the intersection between science and policy. And a lot of times science really just occurs in that theoretical realm, and there's not that direct practical application. But because I'm studying air quality, I'm really looking at and generating results that have impacts on the quality of life of real humans. It's not just about understanding the world and broadening our scientific grasp on how the atmosphere functions, but also that it's about applying these results to improve humans' lives.
Our project involves finding opportunities in the retail industry where we can reduce waste. The entire process is super rewarding because we started from doing background research on the retail industry, especially the furniture industry, and then we started looking at gaps and opportunities, and then we started thinking of ways that we could reduce waste, and then we came up with our product. So the entire process, seeing a product from start to finish, was very rewarding. It is definitely very important, I think, for the Earth Institute to fund projects like this because it really takes away all the worries about logistics and allow us to really pursue what we really want to do. If not, we might not be able to go, or we might be reluctant to participate in such events.
A key takeaway of my project has been that understanding the process flow in any system is only the tip of the iceberg in solving problems and inflicting change. As innovators, I think it is imperative that we dig deeper, understand the market dynamics that underpin systems, and understand competing stakeholder interests before we even define the problem statement. My study also looked at how designing and deploying the right economic incentives to get people excited as a key inflection point or a key leverage point can really enable the restructuring of systems today.
How communities, local governments, and private industry work together in a more detailed way to bring about this energy transition has been really rewarding for the reason that we got to see what we discuss in an academic setting come to fruition in the real world, and that's really encouraging as a sustainability professional. Doing this research kind of has changed my scope and given me real acuity to focusing on what are actually the things that the community cares about when these projects are being developed in their local regions. If we can actually make this 100% energy transition in New York and maintain the economic growth and environmental efficacy of the region, then we can kind of take this example and spread it through other regions.
These communities are organizing themselves to adapt to climate change. In this case, they are eager participants in their water management systems. They are not waiting to receive donations or projects or help from government, but are together coming to solutions for their well-being. This is a truly valuable experience so as to better understand the decision-making behind adaptation towards climate change. And coming from Argentina and interested in the Latin American context, I believe this very particular situation happening in Peru and the responses of these communities to these challenges could also be applied elsewhere in the region or even in the world.
It was a really nice opportunity to get the field experience and then use that, broaden it into the actual research experience, and then work with the data now. I think it's really important to fund these sort of things. Ours was important just in terms of, Staten Island is having a lot more cases of Lyme disease over the past couple of years, and so, our project was really focused on both the natural side of the system, but also the human side. So there was another group that would go out and do surveys of the people, of the residents of Staten Island, and see how much they knew about the ticks that they were coming in contact with daily. So there was a really important public aspect to it, and I think, that intersection between sustainability and public health is not necessarily addressed as much as it should be. So I think it's really valuable that institutions like the Earth Institute are putting money towards that.
Hi, my name is Mitchell Thomas, and last semester I worked with Dr. Michael Puma and Dr. Allison Heslin on a tool to monitor real-time environmental conditions in global refugee camps. Many refugee camps around the world are difficult to closely monitor due to government restrictions, geographical boundaries, or lack of resources. Remote sensing allows the possibility of monitoring these regions for drought, flooding, heat waves, and even population growth from thousands of miles away. By developing a package of Python codes to access and process Google Earth Engine satellite datasets, we developed a tool which can easily extract various environmental variables from these camps simply with an internet connection and a computer. Using variations in the normalized difference vegetation index, a measure of vegetation growth, we were able to draw accurate boundaries around 18 refugee camps in Bangladesh, Syria, and Eastern Africa. With these shapes, we extracted time series of land surface temperature, NDVI, and precipitation over many years and up to the present. We finally calculated some of the most important environmental monitoring indices laid out by the World Climate Research Program. Future work on this project could include forecasting models, greater flooding and drought monitoring, camp size monitoring, and expanding to more camps. Thank you.
Hi everyone, my name is Amanda Abram and I'm a first-year master's student at SIPA. Last semester in the fall, I had the opportunity to intern with the Earth Institute Center for Sustainable Urban Development on the Accelerating the SDGs project with Anna Rubo. So this is a 3-stage research project titled the Local Project Challenge. And what we essentially did was to showcase efforts on accelerating the SDGs and create a network to share local solutions to development challenges. So the project began in 2018 with a survey and a working paper, and I joined during stage 2, where we initiated a call for local projects that engaged with the United Nations Sustainable Development Goals. We received 110 submissions for projects across the educations, the professions, and civil society, and these were submitted by 39 different countries and contacts that are there, and they're featured on the localprojectchallenge.org. Last semester, we also planned the Columbia University Urban Thinkers Campus, which is an initiative of UN Habitat. This was a summit attended by 80 participants and 35 panelists, and it was a great way to actually think of new local solutions and ideas for action for taking this further. And finally, to close out my time with the project, I went to the World Urban Forum in Abu Dhabi in February, where we had an exhibition booth and also had a networking session to really showcase this project and disseminate our outcomes. So thank you so much. I had a great time interning with the Earth Institute the past semester and continuing into this semester, and I'm really happy to share our project.
Hello, my name is Sam Kadama, and with Stephen Cox and Sydney Hemming, I've been working on constraining the erosional history of Wilkesland's subglacial basin by conducting low-temperature thermochronology analyses of pebbles which have been deposited offshore of Wilkeslands by icebergs. Now, what you need to know for this plot is that with younger thermochronology ages, that is being a signal for glacial erosion in this area. Apatite helium is the thermochronometer that we used, and we have our apatite helium ages plotted on the x-axis and the depositional ages of the pebbles from which those apatite helium ages come from on the y-axis. And as we go from older depositional ages to younger depositional ages, the apatite helium age decreases, showing that as we go from the past closer to the present, there is more glacial erosion occurring in this area over time. Thank you for listening.
My research focused on environmental taxation in sub-Saharan Africa. I was interested in finding out what are the barriers to implementing environmental taxation and also in developing a tool to overcome these barriers. In fact, countries in sub-Saharan Africa are extremely vulnerable to environmental degradation, and also they have low public revenues. In principle, environmental taxation could help in both those areas, but in reality, the countries in the region often face significant obstacles in introducing such measures. For example, they have low administrative capacity, and on top of that, unfortunately, there is a lack of guidance tailored to their needs. In my research, I developed an assessment framework targeted specifically at countries in sub-Saharan Africa. This tool is intended to guide policymakers in the decision to introduce environmental taxation. The framework helps them outline their policy goals, identify existing barriers, and ultimately to develop a strategy and design better policies. My research resulted in a paper, which will be published soon, and I also presented it at a global conference on environmental taxation in Cyprus.
Hi, my name is Gabriel Weinstein, and I am an Earth Institute intern working with Professor Jerry McManus. My project focuses on abrupt changes in climate during the last ice age and during the last deglaciation. I work on picking and analyzing a species of planktonic foraminifera called T. quinkaloba. I pick through a core from the North Atlantic a little south of Iceland. T. quinkaloba are calcium carbonate shell-forming microorganisms that live at the surface of the North Atlantic, and they record the global ice volume and temperature as they are deposited in sediments. I primarily used T. quinkaloba data to better understand how Earth's climate varied during the last deglaciation. I hope that my work helps to illuminate by how much and how fast Earth's climate can vary. I'm very grateful for this opportunity to participate in research through the Earth Institute, and I hope you find my work to be interesting. Thank you.
Hello, my name is Injin Shali San, and I'm an undergraduate student studying environmental science at Columbia University. In my project, I aim to reconstruct past variations in ocean circulation and climate using sediment records from Expedition 383, Site U-1543 in the eastern South Pacific. Marine isotope stage 11, or MIS-11, is of particular interest as it is an interglacial period of warmer than present climate conditions in the Pleistocene. Preliminary results show that lighter color sediments, low magnetic susceptibility values, and high coarse fraction weight percentages are characteristic indicators of MIS-11. I will pick the planktonic foraminifera, Geobloides, which are carbonate microfossils preserved in my study interval, and will analyze their stable isotope and trace element compositions to calculate the sea surface temperature and productivity in the surface ocean.
Hi, my name is Dorothy Grant. I am a junior at the School of General Studies studying computer science. This year I was lucky enough to partake in research through the Columbia Earth Institute and NASA CDAC up at Lamont. My research mainly focused on using nighttime lights to help predict and identify socioeconomic trends. So we are using the NASA Black Marble data, which is nightly or daily nighttime light images. So using about 1 kilometer resolution of the luminosity. So we were tasked with socioeconomic trends, and as season is part of the Institution for NASA CDAC, really focused on population density. That is the direction we took it in. So the overall goal is to help create high frequency population density estimates through nighttime lights.
the demand for land to achieve food security and other SDGs, the need for greater transparency around land and ag investments has increased. Transparency is important because information can stimulate responsible investments and contribute to more inclusive outcomes. On the government side, information can contribute to better decision-making and more effective monitoring. For communities, access to information can represent an opportunity to be included in decision-making. And for society as a whole, it is an opportunity to hold the governments to account, to make sure that the money that follows from these investments is actually generating benefits. Current approaches to transparency are mostly supply-driven, where information producers and holders control what to publish and when to do it. With this research, CCSI is working to establish an evidence-based understanding of the transparency needs, demands, and uses of communities affected by these investments and the government hosting such investments. The ultimate goal is to understand how transparency initiatives can move beyond mere disclosure to effectively improve outcomes.
Tidal marshes are very effective at carbon capture and storage. With climate change and rising sea level, it is important that we preserve them given their huge carbon storage potential. This study investigates carbon storage capacity of Piermont Marsh and compares it to our carbon footprint. By analyzing a sediment core taken at Piermont Marsh, we were able to determine its carbon content at each depth layer, which we then used as a reference for estimating the total carbon storage at Piermont Marsh to be roughly 353,000 tons. The total amount of carbon stored at Piermont is roughly equivalent to annual emissions of 280,000 vehicles, or 217,000 New York City residents, or 3% of annual New York City's emissions. Therefore, by preserving as much tidal marshes as possible, we will be able to store carbon in one of the most efficient ways as global greenhouse gas emissions increase by year.
Hi everyone, my name is Emmeline, and last summer I worked on microplastics with Dr. Goose and his team. My research was concentrated on one particular microplastic, which was microfibers. Microfibers are plastics which are shed from clothing during the laundering process. They subsequently enter the aquatic environment and are consumed by lower trophic level marine organisms. Our research sought to determine which fabric type shed the most fibers. To do this, 33 samples of fabric were laundered, both with and without detergent, and the mass of fibers shed were measured. Fabric types included hemp, polyethylene, nylon, tencel, viscose, recycled polyester, polyester, and polyamide. If you'd like to know which fabric type shed the most amount of fibers, please come to my poster.
My research deals with the history of uplift and glacial erosion in the central Transantarctic Mountains, which is the mountain range which separates East Antarctica from West Antarctica. For this project, we attempted to date the development of the massive outlet glaciers which drain the ice of the East Antarctic ice sheet down through the Transantarctic Mountains. The uplift history of Antarctica is still a bit of a mystery because so much of the bedrock is covered by ice. But we're able to know a lot of what we do about the region because when glaciers erode the rocks beneath them, they can carve out enough of the land surface to produce this buoyant uplift response in the mantle, and then we can date that uplift through the radiogenic diffusion of the noble gas helium out of minerals as a function of temperature. My results were able to reinforce theories of a period of major Transantarctic mountain uplift along an extensional rift flank in the Cretaceous. They also align with emerging results which suggest more rapid glacial erosion in the early history of the ice sheet, closer to the mouths of the outlet glaciers, with older ages further inland.
Hello, my name is Serena Tomei. I'm a current student at Columbia SIPA and a student in Dr. Allison Anderson's Practicum on Education and Emergencies semester at SIPA. My research project for this showcase investigates the design, implementation, and monitoring of child psychosocial support programming for informal education NGOs on the Greek island of Lesbos. Lesbos is home to over 20,000 refugees and migrants seeking asylum in the European Union from countries in the Middle East and North Africa. Psychosocial support programming, also known as PSS, is a critical factor in education in emergencies, as it is a significant precursor to learning and essential for academic achievement for children that may have experienced trauma. Through the Earth Institute Travel Grant, I hope to travel back to Lesbos and offer guidelines for PSS activities for an NGO that I worked for several summers, Refugee for Refugees.
Thank you for helping us to celebrate the work of these extraordinary students. As you saw in the video, the work that the students have undertaken is truly fantastic and impacts communities and ecosystems across the globe. Thank you very much.
Thank you everyone for participating in the research showcase. Our students have been very flexible in responding to the situation. We normally hold the showcase in person, but here we are virtually, and thank you all for joining us. Just a few housekeeping notes. My name is Samantha Ostrowski. I work with the Office of Academic and Research Programs. We're going to be moving through a Q&A session with the students. And just note that there's about a 20-second delay between where we are recording and the YouTube Live feature. So please enter your questions on the chat box on the YouTube Live feature, and we'll get started. So our first student is Emily Carrero-Mustelier. Her project is Seismic Anomalies in the Southeastern North American Asthenosphere as characterized with body waves, travel times from high qualities Teleseisms. I hope I said that right, Emily. So Emily, can you give us a quick little overview of your project?
Yes, Samantha, I'm right here. So basically my project is based on identifying and characterizing seismic travel time anomalies in the East Coast of US, mostly from Georgia to Virginia.
Great. What is the broader significance of these seismic anomalies?
So in this side of the country, they are not usual, since we don't have processes going on like convection or volcanism. So by identifying these anomalies, we are able to image the structure of the mantle in that side of the country, which has been a question for the last few years.
Great. How does this research fit into your studies, and how would you like to develop the research further?
So right now I'm using that research to finish my senior thesis. I always wanted to do geophysics. So I basically started with air science, and then I want to go to grad school and do geophysics. And this is a geophysics project. It has helped me to actually see what I can do in the future. Mm-hmm.
Great. What is the most interesting thing that you found from your research?
Well, the most interesting thing was that the anomaly that I wanted to find didn't actually exist at first. But then with the data, we were able to see another anomaly right next to that one and characterize that one instead.
That's really interesting. Are there any related projects that you're interested in working on as you move this forward?
Well, a second part of this project is basically to expand the characterization of one of the anomalies I found, but to compare it to other microcontinents worldwide to see how it fits.
Cool. We have a question from the chat box. What did you find was the most challenging part of your research, and how did you overcome that challenge?
So the most challenging part was exactly the same one that was the most interested. I get overwhelmed when I saw that the anomaly that I wanted to find was not there. And basically what I did is was like, okay, I need to keep looking, see what can I do, what I have now, and move on.
Great, yeah, that shows a lot of commitment to that project. Is there anything else you want to share with us about your research or your project, or you know, what your plans are for the future?
Well, I'm gonna be a senior next year, and like I say, I'm finishing this project as my senior thesis. Let's see what does the second part of the research has to offer.
Great. Well, I hope you'll join us again next year once you finish finishing up your thesis. Hopefully we'll have this again in next spring in our normal fashion and in-person fashion. Great. Thank you so much, Emily. So
thank you for the opportunity.
You're welcome. All right, so let's move on to the next student, who is Mengbi Chen. Mengbi's project was comparing Piedmont Marsh blue carbon storage to New York City's carbon footprint. Hi, Mengbi.
Hi there. Hi.
How are you?
I'm good. How are you?
Awesome, great. So can you tell us a little bit about your research and your project and what you discovered?
Yeah, of course. So this project, I worked with Dr. Dorothy Petit, and then we were primarily looking at the carbon storage in Piermont Marsh, which is one of the tidal marshes along the Hudson River. Actually, it's next to Lamont, and we were trying to figure out how much carbon was stored in the Piermont Marsh, and then we were trying to do comparisons to our carbon emissions, such as how many cars would the carbon storage would be equivalent to. So we found out that the Piermont Marsh carbon storage is roughly equivalent to 280,000 vehicles emissions on an annual basis, or roughly to 217,000 New York City resident emissions. And then throughout this project, we want to show the audience of how important tidal marshes are in comparison to other natural carbon reservoirs, such as the forest or the ocean that we normally think of, because people don't usually think of tidal marshes as an important factor. And then we want to, through this research, show people how important tidal marshes are. Yeah.
That's really interesting. Mm-hmm. Did your research show anything about what aspects of tidal marshes make them more or less effective carbon sinks?
So one of the most important characteristics of tidal marshes is that they are accumulated over a very long time period. So for example, this tidal marshes, the Piermont Marsh that we're looking at, it has been developing over layers on layers since thousands and thousands of years ago. And throughout these years, a lot of organisms or other organic matters have died out in the marsh, and so accumulated as carbon stocks in what we would call as blue carbons in the tidal marsh. And typically these tidal marshes are very rich in nutrients and also rich in carbon content. So that's why it makes them so special, even though they're typically in smaller sizes compared to forests and oceans. So that's why they're very important, because they're very effective at carbon capture.
That's really great. Thank you. Mm-hmm. We have a question for you from the chat box.
Mm-hmm.
Are there any other marshes in the New York City area with comparable carbon storage capacities or near other metropolitan areas?
So these tidal marshes are actually occur at a lot of places. Actually, along the Hudson River, there's actually several other tidal marshes that has great carbon potentials. And going forward, there's definitely a lot of opportunities to look at other marshes that with such huge carbon storage potentials. But Piermont is very special at being itself. It's very deep in depth layer, which some of the marshes might not be so deep, and there are definitely a lot more marshes out there along the coastal lines that we can discover as huge carbon storage potentials. Yeah.
Oh, great. Thank you. That's really interesting. Are there any other things you want to share with us about your project?
I guess one final thought I would share is to have our audience keep in mind of how important tidal marshes are, and then to in the future, take a notice at them and then see what are some of the important aspects of it that makes us want to preserve them or maybe even develop them even further.
That's great. Thank you so much, Mengbi.
Thank you.
So it's time to move on to our next student, Roger CREEL, Reconstructing Last Interglacial Sea Level, Bahamas Field Observations, and Improved Solid Earth Models. Hi, Roger. Roger, you are...
Hi, Sam.
Hey, oh, there you go. You're unmuted. Okay, there we go. So, Roger, and I should note that Roger's drone footage is featured in the introduction to this video. So he had some very interesting images that he found, but do you want to tell us a little bit about your research?
Yeah, so big picture, my research group is trying to figure out what sea level was like during the last interglacial period, which is 125,000 years ago. And it's the last time that that global temperatures were about 2 degrees warmer than they are than they were at pre-industrial levels. So it's a really useful analog for what will happen in the future if we don't cut CO2 emissions. And we try to figure out what sea level was during this relevant period by going to islands in the Bahamas and measuring the elevations and ages of corals that grew during the last interglacial, because those corals give us a way to back calculate what sea level was back then.
Great, thank you. One of the things you mentioned in your video is that coral reefs are the canary in the coal mine. Can you elaborate a little bit on what you mean by that?
Sure. Well, coral reefs are very sensitive to changes in oceanic conditions. Temperature, salinity, changes in sea level, because they grow quite near the surface, and their ecosystems that, because of their complexity, are quite fragile. So corals in the modern environment are going to be some of the first, you could say, the first responders to the climate catastrophe as it unfolds. The Great Barrier Reef is bleaching every few years, and similarly, back 125,000 years ago, coral reefs were keeping right up with climate change as sea levels rose and fell, so we can use them in that way.
Awesome, thank you so much for clarifying that.
Yeah.
What was the biggest challenge you experienced in your field research, and why, and how did you overcome that challenge?
So the biggest challenge in the field research was the weather. We were hiking all day on Bahamian beaches without a lot of shelter and a lot of sensitive electronic equipment. Pretty much every afternoon we would get drenched with a rainstorm, and the drone footage that you saw at the beginning of the video was only possible because we often had to duck into caves to shelter the drone and the differential GPS that we were carrying.
Awesome. Do you have any final thoughts that you want to leave us with?
What I didn't understand before starting to study sea level is that sea level does not rise like a bathtub up and down everywhere the same, but in fact some places experience sea level rise or fall much faster than the global average because of the gravitational effects of ice sheets and the slow rebound that continents experience when ice sheets melt. So I think a main takeaway is that sea level is complex and fascinating to think about.
Great, thank you so much, Roger. All right, so we have to move on, unfortunately. Mercedes de la Vega, her project was local responses to climate change of communities facing glacier retreat in the Peruvian Andes. Mercedes, are you here with us?
Yes, Samantha. Hi, how are you?
Hi, I'm well. How are you doing?
Good, thank you so much.
Excellent. Do you want to tell us a little bit more about your research?
Sure. So I'm currently assisting Professor Ben Orlov in research for a chapter of his book on how mountain communities are responding to climate change and adapting to these new challenges. So I'm specifically studying an indigenous community in the Cordillera Blanca in Peru, that is the area that has the largest tropical glaciers in the world. And just to give you a bit of context, in Peru is the home of 70% of tropical glaciers in the world that are highly affected by global warming. And this community that I'm particularly studying is obviously affected by this because they need this glacier to access water for their daily lives and also for agriculture. So I've been basically analyzing numerous records that Ben Orlov and his team had previously compiled of interviews with members of this community, with different minutes of community meetings called asambleas and also focus groups. And the final objective of the research is to really understand how society and politics can change the way that people perceive and adapt to climate change.
Awesome, great. How are the people in the Peruvian Andes participating in this adaptation, and what kind of solutions are they putting forth? Can you tell us a little bit about that process?
Sure. So this is a very interesting process because the response that the community members have arranged to do has really been born from the same communities. They have not been waiting for a particular response from public authorities, but they have organized themselves to create an organization of the water management. They have developed a system to make more efficient the irrigation of their lands for agriculture. This is an area that depends heavily on agriculture. And to do this, they have, on one hand, for example, put some cement on canals in order to access better water. On the other hand, they have also developed a system with turns where each member of the community can irrigate on specific moments of the week. And there's even a person there called the güero, like the waterman, that is in charge of managing this. So it's a very interesting case of small-scale local response to climate change.
That's so interesting. We have a question for you from the chat box. Do these communities understand their predicament as a climate change impact? How do these communities believe that the problem could be solved?
So the truth is that the concept climate change does not appear much in the interviews. To be honest, it has appeared only once. If they do this connection, it's mostly related with training that they have received by maybe some NGOs or even public authorities. They do, however, make some correlations with glacier retreats and increasing temperatures and changes in nature that are not only associated with changes in the glacier, but also changes in rain patterns, changes in other streams of water. And there's also numerous references to pollution that I think is important to mention, pollution regarding plastics, but also they are near a mining region. So that is another important issue, and even smoke and humo, that is in Spanish, that comes from nearby communities that they understand might have an impact.
Thank you. It seems like a very complex situation. Do you have any final thoughts you want to share with us?
Yes, I would like to mention that the professor I'm working with is an anthropologist, Ben Orlov, and I think it has been very interesting to work with him and understand how to bring a human dimension to climate change, because in the end it is people who have created this challenge, but also people who are adapting to it. So if we really work to better understand responses at national level, global level, but also small scale responses like this type, it will be easier to share a message with everyone and really have a larger impact in this fight against climate change that we're all involved.
It's important to remember. Thank you so much, Mercedes. We appreciate it.
Thank you very much for this opportunity. Bye.
So we have to move on to our next student, who is Emerline Ragunas de Matos. I hope I said that correctly, Emerline. Your project was assessment of synthetic microfibers for clothing in the aquatic environment and implications for zooplankton. Can you tell us a little bit more about your project?
Hi, Samantha. Thank you for the opportunity. So what this project was about, we know that microfibers are being released from clothing when we are doing our laundry. But what we did not know was which type of fabric sheds the most amount of fibers. So what this project sought to find out was determining the fabric type that shed the largest amount of fibers. And what we saw was that the polyamides shed the most amount of fibers when compared with other fabric types. We also sought to determine the effect of detergent use on microfiber shedding, and what we saw was that when detergents are used, there was a larger amount of microfibers that were being shed.
That's really interesting. So you said the polyfibers shed the most, and that laundry detergent makes them shed more. Should we not wash our clothes in detergent?
Actually, it's polyamides that shed the largest amount of fibers. And when it comes to detergents, you need to be mindful of the type of detergent that you are using. We compared like organic brands of detergents to regular popular brands of detergents, and we saw like organic brands contain less microplastics in their formula. So that was you know, an interesting discovery, knowing that we found the detergents, we found microplastics in the detergent formula itself.
Wow, so the microplastics are in the detergent as well as from the clothing.
Yes.
Was there anything else interesting that you found as a result of your research?
We also collected zooplankton species in the Long Island Sound area and Connecticut River, and we saw that the zooplankton, they consumed microfibers as well.
Oh, wow, so you found it in the zooplankton that you studied?
Yes.
That's very interesting. So what were some of the challenges that you faced in your research, and how did you overcome those?
One of the challenges was the drying process. We had like a miniature dryer, and each fabric type had to be dried, and removing the lint after each fabric was dried was a bit challenging. So to mitigate against that, we had to do several cleanings, not just of the filter, but the dryer itself to prevent contamination. It wasn't like 100% removal, but it was still a mitigation strategy.
I see. What is the process for cleaning the dryer?
We took like a napkin, a damp napkin, and we wiped the inside of the dryer itself, and then we took a dry napkin and we wiped that off as well.
Great, thank you. I don't like doing my laundry as it is. That sounds like a terrible project to me, but very interesting.
We had fun doing it.
Oh, good, excellent, I'm glad. So do you have any final thoughts that you want to share with us about your project or what you discovered?
Well, we definitely need to be mindful of the type of fabrics that we use. When you're choosing clothing, you want to choose organic brands of clothing made from natural fibers like cotton, wool, silk, hemp. You also want to be mindful of the detergents that you are using. You want to go for organic brands of detergents.
Great. Thank you so much. We really
You're welcome.
appreciate it.
Thank you for your opportunity.
You're welcome. So we have to move on to our next student, who's Tejaswini Sethi, and her project was enabling waste tracking and data transparency to accelerate a circular economy. Hi, Tejaswini. Can you tell us a little bit about your research? Actually, I think she's actually not on the call. Okay, so we'll move on to the next student, Shelly Sohn. Shelly, are you on the call as well?
Yes.
Excellent, okay, great. So Shelly, your project was reconstructing past warmer than present climate conditions in Southern Ocean, and I can pull up your poster. Can you tell us a little bit about your research while I do that?
Yeah, my project involved me sampling sediments from the Eastern South Pacific from Expedition 383, Site U 1543. And what I did was I wet sieved them, the core samples, core sediments, and weighed the dry bulk sediments and the core fraction sediments bigger than 150 microns. And we aim to ultimately analyze their stable isotope and trace element compositions of geobloides, which are planktonic foraminifera, which means they will tell us something about the surface ocean, and that something is, well, sea surface temperature and productivity. And we hope to see the foraminifera in the 250 to 300 micron. And in the wider context, that would tell us more about the ocean current and climate changes in the Southern Ocean during the MIS 11, which was marine isotope stage 11, a warmer than present day climate conditions.
I see, that's very interesting. So were you mostly, can you tell us a little bit about what your research looked like on a day-to-day basis?
Sorry, could you repeat the question?
Of course. Can you tell us a little bit about what your research looked like on a day-to-day basis?
Yeah, so when I entered the lab, I would grab the sieved samples and then sieve them. I would first open this sample and then weigh the bulk dry sediment, and then I would put them into a sieve and then use water to wash the sediment and then collect the coarse fraction that's bigger than 115 microns. And I would also save the fine fraction into a beaker, and we leave that out to settle at the bottom, and then we will decant the top and then use that fine fraction for later. But more importantly, right now we're focusing on the coarse fraction, which we weigh later again after drying in the oven. And then we pick the foraminifera geobloides specifically. They look like popcorns. You can see the image on the poster.
Yes.
I took the pictures myself. I'm so proud of them.
Oh, that's really great. I didn't realize those were your own photos.
Thank you. It was really interesting looking through the microscope, and it was really cute. Yeah.
Oh.
And later, after picking these foraminifera, 40 of each from each of the interval, which is 1 centimeter interval for each, and we will be analyzing the stable isotope and trace element compositions of each of them. Yeah.
That's really interesting. What did you find was challenging about the research, and how did you overcome that challenge?
Well, there wasn't really anything that was challenging because I started this research this semester, and it wasn't a long period for me to work due to the outbreak, unfortunately. But to say, we are in the very beginning stage of the project, and definitely I had to find which specific method is most effective at best utilizing these sediments that were collected from the expedition. We want to use them well. So finding out the best way was a very intellectually fascinating and fulfilling process for me. It was fun to work in the lab.
That's great. I'm really glad to hear that.
Thank
Are
you.
there any last thoughts that you want to share with us about your research?
Yeah, so it was really interesting to find out that all the preliminary results from this research that you can see on the poster, and I laid out like the lighter color sediments and the low magnetic susceptive values and high coarse fraction percentages, weight percentages, they actually are in agreement with outside research results as well, like the Atlantic ice core results of like the water isotope changes, like the precursor events that occur, that the high spikes and the onset of a much longer warmer period, they are in correlation. So it was fun to see that these results are matching, and I really was happy to have some sort of like a hope that we can actually understand where we stand today in the global context in a much longer context of climate patterns, and we really hope to understand why there was a warmer than present climate conditions in the past, and how it will, you know, be insightful for us in terms of like what our future implications on the Earth system is, depending on the projection of our climate and ocean currents today.
That's great. Thank you so much.
Thank you, and I really thank everyone here and my supervisor, Julie Goschuk, for giving me this opportunity, and the Earth Institute.
Wonderful. Thanks, Shelley.
Thank you.
Okay, so we're going to move on to the next student, and this next group of students is working primarily in the earth sciences. And the first student we have is Dorothy Grant, and her project was Understanding Black Marble Data. Dorothy, are you with us, and can you tell us a little bit about your project?
Hi, yes, I'm here. So my project was working mostly with nighttime light data to be able to create high frequency population density estimates, or at least that was the goal of it. Sorry. So what was really interesting with this is that it's new data, and we have an exclusion on it. So it's going to be public since it's NASA, so it's government, so it has to be public eventually, but we have it first, which is kind of cool to be able to play around with data that's new and try to find socioeconomic trends. And this was an exploratory research, so we could kind of take it in any direction that we found interesting. And we decided to try to create high frequency population density estimates with the data.
That's really interesting. So you were able to sort of identify these population estimates. Were there other socioeconomic trends that you identified as a result of this research?
Yeah, so we actually started off, one of the first things we wanted to see was just kind of understand what can be even told with the data. So one of the first things was seeing if you could tell a difference between a weekend and a weeknight based on nighttime lights from a given city. Or if you could tell, so we knew that we could tell something like holidays, for instance, Christmas, there's a lot of lights up, or a festival like Burning Man in the middle of the desert, all of a sudden there's a lot of lights there, you can see that. So the ones that were more obvious, we knew, but we wanted to see if we could find minute differences, like seasonal differences, weekday, weekend differences. So yeah, we kind of like played around with a lot of trends and noticed that it really depended on the city. For instance, Las Vegas might not be too surprising, had no statistical difference between weekend and weeknights, whereas Chicago did. So it's just kind of understanding like the personality of the city itself.
Oh wow, that's really interesting. Are there any trends did you look at New York City, and were there any trends here?
So we did not look at New York City. One of the reasons is because it's so urban that it's kind of just, because the data is aggregated to a 1 kilometer per 1 kilometer radius. So all of the island is just bright white. So it's not that interesting to play around with unless we go to a higher resolution. And it was also just given to us at first. I didn't unfortunately get to pick and choose the data sets that I worked with. I was given Chicago, Las Vegas, and the whole of Mexico.
Oh, wow.
Yeah.
That's really interesting. So you need sort of places that have a little bit more, aren't quite so clustered together to give you the space to use that spatial,
yeah,
distance. Okay, interesting. So we have a question from the chat box. How did your research experience change your perception of the problem? Did you find a new way to approach your own research questions or interests as a result of your work?
Yeah, definitely. One of the parts was that this was actually originally exploratory. So I didn't come in with any specific question. I actually just let the data kind of guide me to a question, which I was really lucky with, because I don't think that's usually how most research goes. It's usually more, let's find a question and let's have a question, let's answer it. So it was really lucky because I came in completely with an open mind, an open slate, and just really let what I was finding guide me to something that I thought would be interesting. The only thing that we were tasked with was something social, to find like a trend. So eventually where I would love to take this is working with other countries. Unfortunately, once you build a model, it's very specific, as I said, to a specific city, not even a country. So it would be interesting to work with, say, refugee camps, being able to understand something after a natural disaster. We looked at Houston, after the hurricane that was there in 2017. So I really haven't focused on a single thing. The end goal is population frequency, or higher frequency population density estimates, because right now we only have one a year, and it's based on a lot of variables, which are from the governments directly, which aren't necessarily always the most trustworthy sources. For instance, the census is not always the most trustworthy. So what's nice about nighttime lights is that it's really hard to falsify. It's just a satellite that takes images. So it's really neat to kind of have that guide you.
Great, that's really interesting. So we're running out of time. Are there any last minute thoughts you want to share with us?
Nothing very specific other than thank you to my mentor, Kit McManus, who has really been incredible in guiding me through this whole process. And if you have an opportunity to showcase your work at like a presentation or at a conference, I would highly recommend it, because I had the chance through the Earth Institute to do so at AGU in San Francisco, and it was really an incredible event and motivated me to keep going in the field.
Awesome. Thank you so much, Dorothy.
Thank you.
So our next student is Sam Kodama, investigating the erosional history of Wilkes subglacial basin with low temperature thermochronometry. Hi, Sam, are you with us?
Hello, yes, I am.
Excellent. Can you tell us a little bit about your project?
Sure. So we were using pebbles that were initially eroded off the landscape by ice sheets and then deposited offshore by icebergs to kind of tell the past glacial history of the Wilkes subglacial basin area. And we can do that by two main ways, using radioactive dating. One method tells us the provenance, or kind of just like the age characteristic of where those pebbles came from, so that we can kind of map it back onto the continent where the ice sheet was eroding. And then we use the low temperature thermochronology to give us a proxy for uplift rate. So once we realize where those pebbles came from, where the ice sheet was eroding, we can see how much erosion was actually occurring during those times. And this is important because it allows us to put constraints on the paleotopography of this specific part of Antarctica, which is really important for when you're producing ice sheet models.
Great, thank you. So you may have said this already, but can you clarify for me what exactly is thermochronometry?
Sure. So geochronology is when you use radioactive decay to date when a rock formed, when it crystallized initially. Thermochronology uses the same principles, but instead of telling you when a rock crystallized, it tells you when a rock was last at a specific temperature. And there's different thermochronology systems you can use that are associated with different temperatures. So the one that we used is a low temperature thermochronology, which tells us when it was at a very cool temperature, about 60 degrees Celsius last, which is about 2 kilometers deep within the crust. So that's why we use it specifically for uplift, because it's very close to the surface and it can tell us how quickly it came from 2 kilometers deep to the surface.
Wow, thank you. That's really interesting. It's amazing that you can learn that much from a rock.
Yeah.
Pretty cool. So can you tell us a little bit about some of the challenges that you faced in the research and how you overcame them?
Sure. So probably the main challenge was, since you're dealing with pebbles, they're pretty small in size, maybe about a fist or anything like that. And the low temperature system that we're using, specifically, we need apatite crystals. And in the pebbles that we had, they were kind of difficult to come by. And even the ones that we did come by, they were in pretty poor quality, which really degrades the precision and accuracy of the ages that you're producing from those crystals. So we kind of had to pivot, and we were able to get some data from it, which is very useful. But then also we kind of expanded to using other thermochronology systems. Like I said, they weren't necessarily the lowest temperatures, but still low enough temperatures that they could tell us something about what we're getting from the pebbles.
That's really, really interesting. Thank you. Are there any final thoughts that you want to share with us about your project or your research, or what you learned and how you want to take this forward?
It really just showed me how much you can really learn about a rock and all of its history, and actually how, even though it is just a rock, it can be pretty useful for wider spread issues that do with ice sheet dynamics and the implications that they have for sea level change and stuff like that. So it's cool.
That's great. Thank you so much, Sam. We really appreciate your participation.
Thank you.
So let's move on to the next student, Bailey. Bailey Norden is, I think, doing a similar project, thermochronological evidence for glacial erosion and exhumation along the central trans-Antarctic mountains. Hi, Bailey. Can you tell us a little bit about your research?
Yeah, absolutely. So you were right. It's pretty similar to Sam's. I also worked with Sydney Hemming at Lamont, and I got to use samples that she collected from the Trans-Antarctic Mountains, which are this massive mountain belt which separates East Antarctica from West Antarctica. And so we were also trying to use some of these same thermochronologic systems to sort of date glacial erosion in the area. But the idea is that because it's this giant mountain range, which is sort of draining so much of the ice of the East Antarctic ice sheet down through it and then sort of out into the Ross ice shelf, and then from there out into the sea. It's a really interesting site to study, like the stability of the East Antarctic ice sheet over time. Which is interesting because there's sort of this narrative that you have like the rapidly melting West Antarctic ice sheet, and that's where a lot of climate change studies are focused, but we really don't know a lot about like what's been going on with the East Antarctic ice sheet for the past 30 million or so years. Yeah, so that's the gist of it.
Wow. So what how did your research help you address that gap between what we know about, the West Antarctic ice sheet versus the East?
Yeah, my research is a bit lacking in the results department because I kind of got cut short towards the end. So we had a lot of analyses planned. We were going to do this big like transect sort of all along well, not all along, but like in the central part of the Trans-Antarctic Mountains. And so I think in terms of answering questions of like glacial erosion and therefore past intervals of like really fast flowing ice, we weren't really able to make any conclusive claims. Most of my results had to do with uplift, which started with the initial, so the Trans-Antarctic Mountains are actually this uplifted rift shoulder of a rift system where West Antarctica is like the rift basin. And so most of my results were sort of residual stuff from that opening of that rift system. But hopefully the research isn't over, and we will in the future be able to say more about glacial erosion too.
I hope so too. So I've asked a few students this, what challenges did you face? And it sounds like maybe part of it might be your research kind of plan got changed. Is that the case, or do you have other issues that you ran into that maybe made you rethink your project or what you wanted to do?
Yeah, I would say probably the most major challenge was just sort of everything ending. It was a bit frustrating to like be in the crux of like just beginning to be at a stage where we could start getting results and then have that kind of fall through. But I think, I don't know, I've had a really, really good time doing this research. It is so cool to me to get to think about both like the spatial scale of Antarctica and then like time scales of saying like recent events in the last 30 million years. It's really, really cool research. And I think it cemented for me that like there are just so many more questions we have to answer about Antarctica as a continent and how it's developed both geologically and how the topography and the ice sheet have interacted through time.
Great, thank you. Are there any other thoughts that you want to share with us about your project?
I think I don't think so.
Great. Okay. Well, thank you so much for participating, Bailey, and hopefully you can pick up your research again soon.
Yeah. Thank you so much for putting this all together.
Of course. All right. So we're going to move on to the next student, Elizabeth Perry, who worked on monitoring water quality in the Long Island Sound using space stays and shipboard platforms. Hi, Elizabeth.
Hey, Sam.
Hey, could you tell us a little bit about your research and what you were doing?
Yeah, sure. So I was an intern in a lab group based at City College and associated with Lamont Doherty during summer of 2019. This lab is led by Maria Georgiou, and the main research interest include coastal biogeochemical processes, and their approaches include a variety of techniques, including remote sensing data, observational water quality data, and statistical analysis of optical data from water samples. And the coastal ocean is a zone of very important biogeochemical processes, but these are not usually incorporated in coarser resolution Earth system and global climate models. And additionally, these processes are very diverse and very complex. So in order to better account for carbon dynamics and cycling in regional and global climate models, carbon sources and sinks warrant continued study in this complex estuarine zone. So as an intern, I contributed broadly to studies in this field in the Long Island Sound and the Yukon River Delta specifically. I processed water samples on a spectrofluorometer. I participated in field cruises, and ultimately I created a data management tool in MATLAB that organized the lab's field data into a queryable and editable structure.
Awesome. So you said what was it called? A spectrofluorometer?
Yes.
What is that for the lay people among us?
Yes. So during field cruises, the lab would collect water samples, and part of the water sample processing includes assessing them for their optical properties. And a spectrofluorometer basically emits a range of light on the electromagnetic spectrum, and based on the fluorescence coming from that water sample, you can kind of determine the components of carbon in the sample, and ultimately kind of classify their sources, either kind of terrestrial carbon or aquatic carbon, and kind of get into the role of the carbon structure itself.
Wow, that's really interesting. What did you find to be the most interesting outcome of your research, or the most interesting thing that you discovered doing this work?
Yeah, so I think a main takeaway or outcome for me doing this research project was that effective data management is really important for answering complex earth science questions like these. And I had to heavily depend on MATLAB to manage these multi-dimensional data, which was a challenge at the time, but ended up becoming a great skill for me down the road.
And what do you mean by multi-dimensional data?
Sure. So when we participated in field cruises, we collected a number of different water quality variables at each site. And some of these variables were spectral data, for example, absorbance on the electromagnetic spectrum. So in order to organize the lab's data into organize it spatially and temporally, I also had to consider the suite of water quality variables that we were measuring.
I see. Okay, great. Thank you. So we have to move on to the next student. Are there any other final thoughts that you want to share with us about your project or the work that you've done?
I think I covered everything, but I was really thankful to use this opportunity to show me a new area of earth science that I hadn't spent too much time with, and also develop my data management skills.
That's great. Great, thank you. All right, thanks, Elizabeth. So our next student is Mitchell Thomas, who worked on developing a tool to provide near real-time monitoring of environmental conditions in refugee camps around the world. Hey, Mitchell.
Hey.
How are you doing?
Doing well, how are you?
Excellent, thank you. So can you tell us a little bit more about your research and what you were working on?
Yeah, exactly. So essentially, I worked on a tool using Python and a Google Earth Engine, which is a Google software to access satellite data sets, to build essentially a program which accesses these satellite data sets for different refugee camps around the world, and then using different factors we can pull off of them in different measurements, it tries to essentially in real time assess environmental conditions without physically having to be in the camp.
I see. What was the most interesting part of this research for you?
Definitely so I kind of came into the experience with not a whole lot of knowledge about remote sensing, which is sort of the field of using satellite data to detect different trends and stuff. But I think what I came out of it with was the knowledge that you can really pull so much information from just satellites and just from different ways that infrared radiation reflects off of plants. You can tell a lot about how a certain area is doing climate-wise, but also how the people in a certain area are doing. So just the promise that remote sensing has for a really broad range of applications, which are not just environmental, but also human, was really interesting.
Great. Were there any particular findings that you found either regarding the environmental conditions of the refugee camps or any other conclusions?
Yeah. So I think the purpose of the research I did was not so much to come up with something that we didn't know already, but rather it was to provide a way to measure things in ways that we can't. So refugee camps are really often hard to access, and that can be because of environmental restrictions, but normally it's because of government restrictions or political or conflict-based restrictions. So the purpose of this was to be able to detect things such as floods or droughts or heat waves in areas where we can't be physically, and using that to be able to know when we need to supply more aid or help certain people more when from the outside world we have no idea that they're going through a flood or a drought.
Great, thank you. Outside of not having worked with remote sensing data before, were there other challenges that you faced, perhaps in dealing with the data or developing your solutions?
So I think remote sensing data can be really, really powerful, but it also has some big gaps. So spatially there's gaps. So maybe we have a data set that tells us a lot about the Earth, but it only does so over a 10-kilometer radius. So the resolution maybe isn't high enough to really know what's happening in the camp. And then also because of weather. So I did a lot of work in Bangladesh, but during the rainy season there, you might go 3 months without a satellite really being able to measure the temperature. So while there are like really incredible promises coming from remote sensing data, there's also really big limitations. So kind of working within those limitations was difficult.
Awesome, thank you for sharing that. So we're running out of time. Are there any final thoughts you want to share with us about your work or how you want to take this forward?
I think it was just a reminder that I think the most vulnerable people are the ones who are most affected by everything. So whether that be drought or heat waves, or even now like the coronavirus. I think doing this project really reminded me that the things that we take for granted are often not able to be taken for granted by these vulnerable people. So yeah.
Great, thank you so much, Mitchell. All right, so our next student is Gabriel Weinstein, who worked on North Atlantic icebergs and abrupt climate change. Hi, Gabriel.
Hi, how are you?
Good, how are you doing?
Good.
Excellent. Can you tell us a little bit about your research?
Yeah, so I've been working with Professor Jerry McManus and kind of doing similar work, at least in the lab as Shelley, where I'm picking through sediment cores from kind of off the coast of Greenland and Iceland, so kind of in the middle there in the North Atlantic. And I've been picking specifically for this species of foraminifera called T. quinqueloba. And so basically, this is in an effort to understand how past climate was kind of very unstable, especially during the last ice age. And then trying to understand, what does that instability mean? Is it a true signal? Is it across the entire world? Is it just localized to kind of the Northern Hemisphere, or is it even more localized? And so kind of in doing the process of doing that requires kind of just accumulating more and more data and bettering these records. And so there are benthic records, which are same foraminifera living at the bottom of the ocean, which give a temperature and ice volume signal. from the past. And then, so where T. quincaloba comes in is that it's a surface dwelling species. And so the hope is that it shows surface temperature conditions, at least in the ocean, which should be the same, if not very similar to atmospheric temperatures. And so the way you analyze it is through stable isotope analysis, and you run their shells through a mass spectrometer in order to better understand it.
That's really interesting. What was the most interesting part for you about either the data collection or the analysis? And what sort of challenges did you face in those fronts?
Yeah, so actually kind of the challenge and the most interesting part are kind of one and the same. And I think it was that kind of early on while I was picking through these sediments, there was just suddenly a gap where I couldn't find a single T. quincaloba shell in about 50 centimeters of the core. And so what I kind of started to realize is that we separate out the sediments into different grain sizes. And so generally you're looking at the coarse fraction of the sediment, which is relatively large, above 150 microns for each particle. And what I realized was that there were a few very small shells that looked like T. quincaloba, but just much smaller. And they're already a smaller species compared to what Shelley's studying the G. beloides. So I looked, and they also keep the finer grain sediment. And so I started looking through that, and I was finding a lot of T. quincaloba. And so then the question was kind of, are those also a reasonable proxy for past climate? And so I picked through those in kind of an overlapping part of my sediment and into kind of the portion of the core that was missing T. quincaloba. And kind of just examining the correlation between the smaller shells and the larger shells was a big challenge because they were particularly hard to pick, and you need a certain mass to analyze. And obviously if there's smaller shells, it's harder to get to that target mass. And kind of then just seeing, did they work together? And partially they did, but there was kind of also a lot of uncertainty. And so that's kind of where the most challenging part came in, where, getting this data back that was not directly useful. And then kind of seeing, is there another interpretation that you can kind of take to understand it better?
Great, that's really interesting. So unfortunately we have to move on, but do you have any final thoughts that you want to share with us about your project?
I think just similar to what other people have said, I'm really grateful for this opportunity, and Jerry has been a really great mentor. And even kind of during these strange times, he's found ways to kind of inform me on the literature, and I've been able to kind of expand that side of it, which I may not have been able to do otherwise.
Great, I'm really glad to hear that. Thank you, Gabriel.
Thank you.
All right, so we're going to move on to another group of students working on health and international development. The first student is Dan Panichik, who worked on the psychology of winter park use in New York City and climate change perceptions. Are you with us, Dan?
Hi, hello.
Hi, Dan, how are you?
Good, good. How are you? Thank you so much.
Good,
for,
thanks. So can you tell us a little bit about your project?
Sure. We were studying winter park use in New York City, and specifically in 3 parks, in Riverbank State Park, in Marcus Garvey, and part of Central Park, with the goal of understanding if park use during the winter is different than during the summer, and if there would be different climate perceptions around climate change among the users of these parks over winter. Kind of the motivation of this research is that that cities are becoming huge population centers around the world, and especially on the global north, winter is taking 7 or 8 months of the year somehow. So we really wanted to understand a bit better this.
Great, thank you. What were some of the biggest takeaways from your research and the work that you've done?
Well, I would say that some of the biggest takeaways are that people are concerned about climate change. One of the questions was how important climate change is for you from 1 to 10, and our average was 8.5. And actually, most people were closer to 10, with some outliers just like going into the 1s and 2s, which kind of skewed the average. We're trying to figure out if this kind of changes between parks, between age, between some other socioeconomic factors, and that is an ongoing process. And also some other insights is that, for example, people have some difficulty operationalizing climate change. Several people find it relevant, but it's one of the questions was, okay, so how would climate change affect this park in particular? And then people had some sort of trouble, but in the end, most people found climate change happening and occurring, and had general insights on how it could affect the park and the world in general.
That's interesting. Did those findings that you discover affect how you looked at the problem that you came in with, the question that you came in with?
Yes. So we had several interesting answers. Some were, for example, people concerned that maybe climate change would imply longer winters, and in that case, that would affect the urban setting of the park. For example, that was an interesting insight. Because, for example, some people were saying, okay, we come to the park to do sports, but if we have like longer winters, then less people would come to do sport, and maybe more people would come, I don't know, like to the park for other things, which like affect the neighborhood, for example. And I think we had really interesting answers differing in each park. For example, Riverbank State Park, which is a very, it's a lovely park between 137 and 145th, which is kind of an artificial platform that stands above the river. We have a lot of interesting responses there on climate change, rising the water levels, the park going to disappear. And we had different answers in Central Park and Marcus Garvey according to kind of the setting and the reasons why people go to those parks.
That's really interesting. Thank you for sharing. So unfortunately, we do have to move on. Are there any last things you want to share with us quickly?
Sure. First place, and actually I really want to start with that. I really wanted to thank my advisor, Megan Maurer. She was amazing. Without her insights, her continuous support, the project would not have happened, and I'm super grateful of her support and of the Earth Institute of allowing this opportunity for students.
Great. Thank you so much, Dan.
Thank you.
Okay, so our next student is Amanda Abram, who worked on accelerating the SDGs, the Sustainable Development Goals. Are you there, Amanda?
Hi, yeah, I'm here. How are you?
Hi. Can you tell us a little bit about your project?
Yeah, of course. So like I said in the video, we issued a call for local projects that engage with the Sustainable Development Goals as a way to feature them on the website and kind of create network sharing. So we had 110 projects, and we kind of analyzed them to see what aspects of the Sustainable Development Goals were integrated in those projects. It was a range of projects, from things happening at schools and universities, from architecture projects in cities. And yeah, so then we made this website to feature all of these solutions.
That's really interesting. Were you able to draw any conclusions or best practices from all of these projects that you looked at?
I think because they were such a wide range of projects and we didn't really limit any of the sustainable development goals, we looked at all 17. We found that there was a lot of different solutions happening. A lot were focused on sustainability and things to combat climate change. We had projects submitted that were happening in Brazilian favelas, all the way to things happening in Senegal. We had projects focusing on shelters and different housing, things happening in schools, and even things in New York City related to community gardens. So I think it was just a way to showcase all the amazing things that are happening around the world, because I think often you see things like that are very negative, that we're not doing enough to combat climate change. And of course, we still have a lot of things to do, but it's a way to kind of showcase these best practices and things that are actually can be adapted from that are working really well in communities.
That's amazing. Is there any one project that stood out to you in particular?
Yeah, there was one that's actually, I'll share a local one that's happening in New York City, since we're all affiliated with Columbia. There's an organization called Grow NYC. So they have like thousands of students and corporate volunteers come through their community gardens every season. They have workshops and camps and things like that for young students. And what they did is they integrated the sustainable development goals and different plaques and different workshop centers throughout all of their community gardens. So as the children are going through, they learn about climate change and sustainability and protecting our oceans and kind of ways to take this back with them. So I think that was one of the projects that I really loved, because we were really promoting local development solutions, and it's great to see what's happening in the city around us.
That's great. That's wonderful. So we do have to move on. Are there any final thoughts that you want to share with us about your project, what you learned, or how you want to move forward with this?
We're definitely thinking of new ways to take this forward, whether that's engaging with schools and kind of showing them these best practices. I think one of the best things that happened throughout my internship was actually planning the summit, the Urban Thinkers Campus Summit we did last semester at the university, which was attended by 80 professionals. And we had an outcome document after we looked at these projects with ideas for action. And I think, you know, that's the most important thing, is what is the community and professionals and students actually going to do to kind of take action and solve these challenges.
Great. Thank you so much, Amanda. That's a great outcome. All right. So unfortunately, we have to move on. Our next student is David Bassini Ortiz, who worked on promoting targeted and effective land transparency. Are you with us, David?
Yeah, hello.
Oh, hi. Okay, I'll get your video here. Can you tell us a little bit about your project?
Sure, absolutely. So in this project, I worked at the Columbia Center on Sustainable Investment with Sam Zuckerberg, who is a legal researcher there. And so this research it's kind of like the first stage of a research project at CCSI that is trying to promote a different way to do transparency, because currently transparency is mostly, or it seems to be, supply driven, where information producers and controllers decide when to publish information, what to publish, how to do it, and often it's too long, it's inaccessible, etc. So in this research, I went very deep in the literature, and there were also some few interviews, and I mostly focused on the government perspectives. It's a broad project that needs to understand like the different components and actors that get together on large-scale investments, such as corporations, communities, governments, civil society, etc. So I went very deep into the government perspectives, incentives, and disincentives for transparency. And well, it does turn out that there is a lot of work that has to be done if we want to move from mere disclosure to effectively improve outcomes. Disclosed information on part of the government is incomplete, inaccessible, inaccurate, and too technical. Government officials, especially at a local level, are very selective with information they choose to disseminate. And of course, not all countries have like a relevant disclosure framework. So it was really interesting to see the information that came out with this research, because not a lot of, I don't know, it seems like transparency is oftentimes a topic that is overlooked, unfortunately, but it is quite relevant.
Mm-hmm. Are there any particular barriers to data transparency that are common, and are there ways that we can overcome those barriers?
Sure. So perhaps the main barrier could be, so important to point out. So the results or the findings from my research are mostly are influenced by the type of documents that I looked at, which are more like technical, from the FAO, the World Bank, etc. So yes, there are technical barriers. For example, information that is published is it's in languages that, for example, communities may not understand. Like they may not even speak English or Spanish or whatever language is relevant. There's also, it's like the information that is being disclosed is too long. Like it's just drowning like readers of information with just thousands and thousands of pages. And what to do to overcome this? Well, I would say it's a working process, because you need to find, it's important to find what the right information is and at the right moment. So it's a work in progress. It's very interesting, but yeah.
Great, thank you so much for sharing. So it's time to move on. Are there any final thoughts that you want to share with us about your project, what you've learned, or how you want to take this work forward?
Sure. Well, I should have started with this, but I want to thank the Earth Institute and CCSI for the opportunity to work on this very interesting research. And I would say just keep keep your eyes peeled to see the product of this research. Right now, my findings of my research are the basis for the next stage, which is looking at a political economy analysis to be able to understand the incentives and disincentives, at least in the government side, for transparency.
Great, thank you so much, David.
Thank you very much.
All right, so our next student is Elena Belletti, and Elena's project is Environmental Taxation in Sub-Saharan Africa, Barriers and Policy Options. Hi, Elena, could you tell us a little bit about your project?
Hi, Sam. Thank you very much for having me here. So as you mentioned, my project focuses on environmental taxation in Sub-Saharan Africa, and this region is particularly interesting because out of the 46 countries in Sub-Saharan Africa, 30 are considered least developed countries, which means that they share a lot of issues related to low public finance, high inequality, and also they're very vulnerable from an environmental point of view. And I was interested in environmental taxation because it's a tool that can address both the socioeconomic and the environmental problems. But it's also true that these specific countries face kind of unique barriers in designing and also in implementing this tool, and there is also a lack of specific guidance to them. So with my research, I was trying to identify some of the common barriers, and the ultimate goal was to provide an assessment framework that could help policymakers, first of all, in assessing the barriers specific to their country, but also to identify what their ultimate goals are to design more effective policies.
That's great. So can you tell us a little bit about some of the conclusions that or the solutions that you came up with as a result of this work?
Yeah, absolutely. So basically, some of the most important barriers that I found are, first of all, the low political acceptability of these measures, and also low administrative capacity. And for these barriers, what I found was that easy solutions would be, for example, to design simple instruments that would be easy to roll out and implement quickly, even with low administrative capacity, and also to enhance transparency and introduce first simple environmental taxes that can have immediate and visible results to enhance and ensure public support. But also, of course, my recommendation is that each country should assess their own priorities and their own barriers.
Great, thank you. So I know that you presented your work at a conference on environmental taxation. how did that go? What kind of feedback did you receive on your presentation?
Yes, actually, I presented at a conference which is called the Global Conference on Environmental Taxation, and it's a yearly event. And it's very interesting because there were policymakers and representatives of academia from all over the world. And it was very interesting to see, the reaction of policymakers actually from the specific region and also from different regions, and to discuss with them how they sometimes face exactly the same barriers even in other regions of the world.
Great, thank you. There's a question from the chat. Will you be able to share your assessment tool with policymakers in the region?
Yes, actually. So the paper is going to be published soon. It's going to be part of it's going to be a chapter of a book that is going to be kind of the proceedings of this conference. I hope that this book will reach specifically, people from the region, because there is really kind of a lack of guidance.
Great, thank you so much, Elena. Do you have any last minute thoughts you want to share with us before we move on?
Yeah, well, I would like to really thank the Earth Institute for the funding, and also Professor Sarah Jotham for her mentorship. And I would also like to kind of leave with a final thought, which is that environmental taxation is coming under a lot of pressure in this moment, given the current situation. But it's also because we tend to see development and environmental protection as mutually exclusive. And I hope that my research helps, sharing the thought and the idea that these two are not mutually exclusive, and there are a lot of areas for achieving both of the goals.
Great, thank you so much, Elena.
Thank you.
So our next student is Christy Day, who worked on a cost-benefit analysis of oil production in Guyana. Hi, Christy.
Hello. Hi, how are you?
Good, how are you doing?
I'm well.
Excellent. Can you tell us a little bit about your work?
Yeah, so this is my senior thesis. It's a combined thesis with the economics department here at Barnard. So basically, I wanted to go about finding out what are the trade-offs for a country like Guyana entering the oil industry.
Great, thank you. What did your research look like on a day-to-day basis? Can you tell us a little bit about your process?
Yeah, so in terms of like methodology, it comprised of like 3 main parts. The first one was an interview. So I got the grant and I went down to Guyana and interviewed ministers and government officials just to get a political sense of what they're thinking about with regards to entering the oil industry as a supplier. That was one part of it. And then I came back to campus, and my mentor and I worked on a cost-benefit engine in order to put values to different variables within our equation.
I see, that's interesting.
Mm-hmm.
What was the most difficult part of building that cost-benefit engine? And do you have any preliminary results from that?
Yeah, so I think the most difficult part was just agreeing to what you're going to include in the equation, like what do you want to account for and what things you may be leaving out. I think that it just really, the hard part was just trying to get like all perspectives within the equation. Me, myself being an economics and an environmental science major, I really battle between, like making sure that I'm including all parts of the situation. And in terms of results so far, we've run a couple of scenarios, and right now the results is showing net negative with regards to the pros versus the cons of entering the oil industry. But this, it must be noted that that's taking on a global perspective in terms of the social cost of carbon. So if Guyana was to not take that into account, it would then be a positive situation for them.
Interesting.
Mm-hmm.
So we're running out of time here. Are there any other conclusions or challenges that you want to share with us, or ways that you hope to bring this project forward?
Yeah, at first entering the project, I really thought it was just going to be a an analysis between the environmental versus the economic side of things, but throughout my research, I've noticed that politics and the political arena has a impact on the success of Ghana entering the oil industry. Also to moving forward, I do intend on sharing my ideas with the government of Ghana and working alongside to come up with great policy recommendations. And lastly, I'd just like to thank, of course, like my mentors, my advisors. So that's Jeff Schrader, Jackie Klopp, and Professor Harrison, helping me work through this process and thinking alongside me. So also to the Earth Institute for providing the funding to do such research.
Great, awesome. Thank you so much, Christy. It's a great project. All right, so we have two more students. The first is Darren Rabinowitz, whose project was The Right to Belong, a mixed method study of self-reported feelings of belonging in Rwandan orphan and vulnerable children and their perceptions of national peace building. Hi, Darren.
How are you?
Good. Can you tell us a little bit more about this project?
Yeah, I'm happy to. So my project was a convergent mixed method study in Rwanda with orphan and vulnerable children. So basically I was measuring with a survey feelings of belonging, how students understand belonging in the post-conflict context, and also given their vulnerable backgrounds. And in addition, I also asked them, I had focus groups and I asked more about how they understand their participation in the peace building process, given their vulnerable backgrounds.
Great, thank you. Did you face any challenges in working with the students, and were they always willing to talk with you, or, you know, like Kids Anywhere, were they reticent and, you know, oh, I don't want to speak to this person?
Sure. So I think one of the challenges with working with students is the language barrier, is that there was a bit of some challenges with using Kinyarwanda and English. Kinyarwanda is the mother tongue of Rwanda. And also given the language of instruction in Rwandan schools across the nation changed in 2008 from from French to English. So in terms of having a translator, it was really important to be able to really understand what the students were trying to relate and trying to share with me. And in addition, just protecting them as minors regarding just, you know, protocols was also quite a bit of a challenge, but I think what they shared with me was really fascinating. I'm really glad to have worked with them and them being open with me.
That's great. Were there any other parts of the project that you found very interesting, or particular conclusions that were unexpected?
Absolutely. So there was 3 findings that I really thought were quite fascinating. One is when I asked them an index question on the survey, how they understand their own belonging. And I broke it down to 4 different sections of influence, membership, integration and fulfillment of needs, and shared emotional connection. And what I found is that across those 4 categorizations, most of them reported quite high, about 90% on average with each of those classifications. But one that was significantly less was membership, which really gets at how they understand their belonging as similar backgrounds and past experiences. So what that tells me is that there is a bit of shedding of their vulnerable backgrounds when they come to this school, and they really try to reimagine themselves to maybe perhaps fit in. Another interesting finding that I found is that when I asked them who the primary agent of peace building was in their country, 53% of the students said that it was they themselves who are the primary agent, which really harkens to this idea that the national narrative of Rwanda in the post-conflict context really focuses on the youth as the primary agents of peace building, and that they themselves must lift their country and place it into a peace building process, rather than the government or other international agencies. Which is also coupled with this idea that the youth were the primary agents of violence in the genocide itself. And the third is when I asked them how they then foresee themselves participating in the peace building process, and this mostly came through the focus groups, they shared with us, they shared that that it was actually through economic participation that they felt that they were able to contribute to the future of their country over perhaps political participation or other sorts of you know, social interaction. And that was really fascinating because they shared with me is that when they felt that they can contribute in that way, they can at least you know, contribute in the way that maybe their families were never able to contribute to their lives.
I see. Did these findings shape how you view the problem and the questions that you came in with? And did it change how you approached these questions or how you would approach them moving forward?
Yeah, and I think what I found is that belonging really during the genocide was politicized and was leveraged to be able to stir up and cause the conflict, and particularly the vulnerability of youth was leveraged to be able to incite more violence and them being primary agents of violence. And so I think what this research really allowed me to find is that there was this pressure in a way, and the national narrative is placed on youth to be able to be the sole bearers of peace building in this country, or really taking upon themselves to see themselves as the agents of reconciliation. So really with these findings, I come to now think that further research is needed in a space where in what does national narratives mean to vulnerable populations in the post-conflict context.
Great, thank you. So we have to move on to the last student. Are there any final thoughts you want to share?
Yes, I want to express my sincere gratitude to Susan Garnett Russell, who helped me craft and construct this research. I also want to thank the school that hosted this research. And in addition, I want to thank the Earth Institute for providing me the funding to be able to go to Rwanda, conduct this research, and also present the findings with you all. Thank you.
Great. Thank you so much, Darren. All right, so our last student, and thank you all for holding on, is Serena Tomei, who worked on child psychosocial support programming for informal education NGOs in Lesbos, Greece. Hi, Serena.
Hi, how are you?
Good, how are you doing?
Good, good.
Good. Okay, can you tell us a little bit about your project?
Absolutely. So my research had two interrelated goals. The first was to conduct interviews and in-person visits with coordinators of education and psychosocial support programs for informal education NGOs on Lesbos, supported by the travel grant, and at the same time offer recommendations and best practices to an NGO that I worked with before starting at Columbia, in accordance with the Interagency Network for Education and Emergencies Guidance note for how to best structure their child youth space. So I was able to conduct many interviews on Skype, and I was planning to travel with the travel grant over spring break to do the in-person portion of my project. However, it got derailed for a number of reasons, not just Corona. So it really reflects the reality of the difficulty of this programming on the ground. Yeah.
Great, thank you. What were some of the most interesting conclusions or findings that you came across as a result of your work?
So informal education NGOs are those that are not necessarily supported by official bodies like the UN or established organizations. So they face a lot of challenges in their programming. Limited funding is a huge issue. Guidance is also another huge issue because they don't follow official guidelines that are established for, let's say, official education NGOs on the island. Most of the NGOs on Lesbos are informal, and they face significant funding challenges, and then they choose to distribute these funds to programs that are not do not have an emphasis on psychosocial support, which is very difficult to work around with, just because psychosocial health of children is a very important precursor for their ability to even learn. So discovering that they don't choose to distribute funds to this area was a little disheartening, also because of the very volatile nature of life in the refugee camp on the island. So there needs a lot of work to be done in that area, and there needs to be a lot of advocacy towards increasing funding and increasing importance to these kinds of programming.
Great, thank you. There's a question in the chat. Why were you interested in this research?
So this, like I said, was something that I worked for before coming to Columbia. I supported an NGO and their youth space, but I noticed it was very informal, very unstructured. And I came up with a lot of questions for me about, the ethics of doing these kind of programs if there's no guidance and if there's no sort of support for volunteers and staff who are engaging in very difficult psychological issues with children who have experienced trauma and violence. So I wanted to use what I learned in this course under the guidance of Dr. Allison Anderson to help bring recommendations and best practices for that organization.
Great, thank you so much, Serena. So we're at the end of our time here. Are there any final thoughts that you want to share with us? You get the last word.
I do. So of course, a thank you to you, Samantha, to the Institute for providing this opportunity for me, to my advisor, Dr. Allison Anderson, for being very supportive. And I just want to end on a more general note, which is that all of these children living in the refugee camps in Europe, you know, they don't have the chance to go back home. Realistically, they will not go back home. In the interest of their future prospects, in the interest of international development, we can no longer ignore conversations about including refugees into national systems moving forward. So
great. Thank you so much, Serena. Thank you to everyone for participating in this showcase in a less than ideal circumstance. And thank you all for watching. The students did a great job, and we really appreciate your tuning into this. So please check out the Research Showcase website, which shows all of the students' work, their posters, and you can view this video and videos of interviews with the students. So thank you all for tuning in, and have a great day. And we hope to see you next spring in person. Thank you.